Hello and welcome to another of my videos where I go through the Everybody Codes 2025 challenge many months after the challenge has already happened. This will be quest 20. This will be the last of the quests. I don't know whether this will be the last of the videos in the series because I plan later to try to optimize things, have a round of that like I did with the 2024 challenge. And as I said at the end of my last video, I also want to make some sort of explainer video or videos where I go through the problems, or at least the ones that I thought were particularly interesting, or especially ones where the solution and the thought behind it isn't necessarily obvious just from the code and would benefit from some further talking. So anyway, with that out of the way, let me start the timer and open up quest 20. Okay. Trampoline or an empty space that leads into a void. Okay. Okay, so the question is, how many of these lines between trampolines exist so that I can jump? Interesting. Interesting. Okay, and now, and next I forgot to make my boilerplate, so okay, I'm just copying quiz 19 and we'll just fix it as we go along. Okay, so first off, I have to decide how to represent these things mentally. Okay, so really doing this, every time I have two t's next to each other, that works. And if I have a t that is, so here, that 1, 2, 3, 4, so 0, 1, 2, 3. So the character at index 3 there is adjacent to the character at index 3 there. And the character at index 4 here is adjacent to the character at index 4. But the character at index 3 and character at index 3, they are not adjacent. Yes, and here we have character at index 2 and index 2, and they are not adjacent. So, two characters are adjacent if they are adjacent in the same row, or if they are in the same column and the parity of the column they're in matches the parity of the higher row. Okay, so grid make byte 0 for scanner.scan grid.append byte scanner.text. Okay, and then what I do type okay, return tote calling it 0. Okay, so I first want to count all the ones that are adjacent horizontally. So for row IDX row in range grid for call IDX range dot ch if ch is equal to t and previous ch is equal to t tote plus plus byte. Oh, whoops. Range row. Okay, pch equals ch. Byte. Okay, and actually I can just say underscore here. You know what? No. If and then what I do is okay, so I want it so that these are not adjacent. So if this is row 1, so I'm always going to be, yeah, so this is row 1 and that's column 2, so I don't look up. If row IDX greater than 1 and 0, and call IDX %2 is equal to row IDX %2, and grid bracket row IDX -1 bracket call IDX is equal to T to ++. There. That should work, right? 133. Now, okay, I've played a little fast and loose there. I wasn't sure if I would get it, but yay, it worked. Okay, roughly in the center of the entire map, E, S, minimum number of jumps. Okay, so okay, minimum number of jumps. So I can just scanner scan type word struct xy int is font s font word -1 if strings.index scanner.text s if sidx greater than 0 s equals Okay, and I'm just going to do I'm just going to do a simple breadth first search. Make map of chord to int. Scene bracket this spot equals 0. Recent chord s spot. And now I'm going to do 4. Return scene e spot. Okay, and now new recent make chord range. I'm going to check if already right. So yeah, so I just have IDX and I have the distance is already there. So I just check up, down, left, right. Yeah. Up. Okay, for jump, range, chord, 1 0 0 1 -1 0 0 -1. Okay. Actually, what I'm going to do is range new chord r.x r.y plus. Yes, I know I'm using y to mean horizontal and x to mean vertical. It's fine. New r. If already colon equals scene new R already. Continue. If new R dot Y less than 0 or new R dot Y greater than grid bracket new R dot X length. Yeah, you know what, I should, nah. Hey, I'm debating whether I should go back and change that to a map, but I'm not gonna. And then, okay, if grid bracket new R dot X bracket new R dot Y is equal to T, then new recent dot append new R, and then scene of new R equals scene of R plus 1. And okay, and now if R dot row, so R dot X so if R dot 2 is okay, actually, if so, wait a second. If column X equals row X, then we check row minus 1. Yeah. If okay, this is going to be a ridiculous amount of copying and pasting, and so really I should find a new way to okay. First of all, append on plus 1, and then less than len grid of x. Okay. Okay. We don't need that. Okay, so yeah. We also don't need that anymore. Okay. Looks good. Download. Move. Oh, I never end up using eSpot. Three, 6. No! Damn. Okay. Okay. So clearly I did not do this right. Okay. So we're going to try this. And we are going to go over here into input, call this quest20 p2 samp. P2 samp. Okay, and that says 17. Interesting that it says 17. Print line Okay, so first of all, that's just very wrong, because S is going to be down here, and everything else should be one more than that. So okay, so clearly I have something weird going on there, like those should not be ones and twos and everything else. So the only time I put something into recent is there, and I always do that. That's really weird. Let me make sure I'm finding S spot correctly. Okay, S spot is 8, 8. Okay, that's good. When do I have 0, 0? So I am going to here. I'm just going to walk through this with the debugger, because I don't know what's going on at all, and the debugger might help us. Oh, no, that doesn't run. Start debugging. Okay, so new R's. So R is 8, 8. And what is scene? Scene is okay, so we've already added 0, 0, and 1 there. Why have we done that? Because we've added 0, 0 to that. Oh! Duh. Okay, and now we say 32, and is that in fact the right answer? Yes, it is. Okay, so let's go back to this, 585. Yay! Okay, so, stupid mistake here. When I wanted to make this be a new empty list with a capacity of 3, and I accidentally made it an empty list with 3. Okay. Fine. More or less in the center of the new formation, the whole map starts rotating. The entire space behaves as if controlled by a giant wheel. Each of your jumps, the map rotates exactly 120 degrees clockwise. Changes as follows. what is this? Boom. Okay, so the different ways, so I still think we can do this, but we have to account for staying in place while the whole universe rotates. Right. Okay, now this T here corresponds to that T there. No. Wait, does it? This T here corresponds to that T there. Okay, so I have to work out the coordinate transformation. Oh boy. Okay. This is, okay, so okay. Okay, so in fact, what I'm going to do is I'm going to teleport the duck a third of the way counterclockwise and then look from there. Sure. That probably works. What? Why am I not able to copy this? Copy. Paste. Copy. Paste. Okay. Weirdness. So what I have to do here is all I have to do is figure out this coordinate. And actually, in order to do this properly, I'm going to need the rows. Okay, so I'm transforming this duck counterclockwise. So at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, so at index 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so a duck here goes to here. Row count minus 1. Row count minus 1 goes to row 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 18. 2 times. Okay, so a duck there goes there. Two times row count minus 2. Zero comma 0 goes to right. Control C no longer copies. Great. I don't know if you guys have ever noticed this, but with Windows 11, sometimes it has a problem where Control C will just stop copying. I don't know of a way to fix it. I think that there's something you can restart, some commands you can run to restart, but I usually have to just reboot the machine, which I'm not going to do right now. Okay, so we've got to get this duck transformed counterclockwise. Okay, so okay, so one way to do it would be if you are at, so a duck in row n has edge pieces at column, not just a duck, at index n has edge pieces at column n and at column 2 times row count -2 minus n. Right, because this copy has length 18, right? Wait, that has length 19? Yes, that is length 19. That's okay. That's okay, because it has yes, it has length 19 because it has at 0 and at 18. Gotcha. Okay. Okay, now, if we are, now these pieces on the edge, they're always facing that way. So now, so the piece on the left edge will go over to some piece on the right edge, somewhere. Actually, we know where. The piece on the right edge will go to somewhere on the top edge. And we know where on the top edge. So the piece at n comma n goes to n up from the bottom, goes to row count -1 minus n, comma, and then whatever the 2 times row count -2 minus that, so row count row count wait, n comma n goes to, and to the last one there, which is this, so for instance, this piece at 0, 1, 2, this piece at 2 ends up going to that piece over there, which is an index 1 and triangle triangle 0, 1, 2, 3, 4, 5. Index 1, triangle 5. 2, 2 goes to 1, 5. What is this? 1, 2, 3, 4. This is a 4. So oh, right. Plus n. 2 times row count minus 2 goes to, so n comma n goes to, so 2 comma 2, so 2 comma 2 in a row count of 4, 2 comma 2 goes to 1 comma 5. Exactly. Okay. Whew. N comma n goes to that, and then n comma that, n comma that goes to 0 comma well, that should just go to 0, 1. Zero comma n. It just goes to the top. Wait. 2 times n. Yeah, because okay. Now let's test it by checking when this is row count minus 1, row count minus 1. Row count minus 1, row count minus 1 goes to 0. Okay. Which is the same as that. Okay. Good. So those are all correct. Now, what about something in the middle? If we have something there, so to go in this kind of diagonal up and left direction, we reduce row by 1 if we can, or we reduce column by 1 if we can't. And we can reduce row by 1 when we are matching the parity, right? Because this will be index 0, 1, 2, 3, 4, 5. Where in row 1 we can match parity, so we can do that. Okay, and then to go okay. So here's what we do. we transfer, okay, so duck row start is chord duck dot x duck dot x. Okay, so it's row duck row start tx chord copy paste duck dot x duck dot x duck dot x duck dot x for duck row start duck okay, and actually, so then let's rename this working tx. Move okay, so working equals y plus plus if working tx dot x percent 2 equals working tx dot y percent 2, then we can do this. We can say just -1. Working tx dot x minus minus. Else working tx dot y minus minus. Okay. I think that works. I just hope that oh wait, I've also got to account for and here we've got to say scene of our old and to do that. 485. Yay! Phew! Just over an hour. Ugh. Ugh. Yeah, it took me entirely too long for this, but I don't know. This wasn't so bad. I just tried to do way too much of it in my head, I think. So, yeah, this just, yeah. Okay, so let's watch the little animation they have here to show my dragon duck getting like more dragony and also buffer and yeah. Yay! Twiddles around. Oh. Oh. And then there's a little thing to read at the end. Okay. The Order of the Golden Duck. Okay. Hats off to your artists there. Those are nice little nice drawings and nice animations leading you through them. Okay, well, that concludes all the quests, and as I said, I will put together another video here about optimization, and I will try to put together a slightly faster paced video about that talks about these problems and talks about some of the solving I did. Thank you for watching this, and I'll put up end cards. You can see all of 2025 challenges and also everything I've done with Everybody Codes problems. Thank you and goodbye.